problems from the sheet. So, wave optics sheet 1. Problem number 1. We are talking of a YDSE setup. This is the screen on which the interference is observed. This is slit S1, this is slit S2. And say they are separated by a distance small d. And let's say this is capital D. Now this time we have the upper slit and the lower slit both covered by a thin glass plate. The upper one is covered by a glass plate of mu equal to 1.4. The lower one is covered by a glass plate of mu equal to 1.7. Right? And each of thickness T, each of the plates is of thickness T, that's given. Now, and the wavelength of the interfering wave trains is 5400 angstroms. You know how much is an angstrom? 10 to power minus? Minus 10 meters. Right. Now, it is found that a point P on the screen, where the central maximum n equal to 0 fell before the glass plates were introduced. Now, if there were no glass plates, where would you see a central maximum? At this point, right? At this point is where you would have seen a central maximum if the glass plates were not there, right? Now, this point is no longer a central maximum after introduction of these glass plates. At P, we have 3/4 the intensity that there was when there were no glass plates. You know what I'm saying? Now, when there were no glass plates, then at P, phase difference was 0. At P, phase difference was 0, right? Isn't it? Part difference was 0, phase difference was 0 without the glass plates. The intensity then at P would have been the intensity coming from S1 plus intensity coming from S2 plus 2 root I squared cos delta phi. 2 root I squared cos delta phi. Right? That is like 2I into 1 plus cos delta phi would have been the intensity at P. Right? Before the glass plates were introduced. Now, where cos delta phi is 0, so this would have been 4i. This would have been 4i. Because cos delta phi would have been 1 for delta phi equal to 0 at P before introduction of the glass plates. Now, after the glass plates were introduced, the intensity at P was 3/4 of 4i. That means was 3i. Yes or no? That's given in the problem. The intensity was 3/4 the intensity seen before introduction. That means 3I was the intensity. Now let me figure out, after the glass plates were introduced, if this was the intensity, then what must have been the phase difference? The phase difference then couldn't have been 0, right? The phase difference is now something else at P. Let me find out the phase difference at P of waves coming from S1 and S2. So now, after glass plates introduced, phase difference delta phi is the phase difference PD at P, phase difference at P of the two interfering wave trains, and 3I is the intensity, resulting intensity, that must be I1 coming from S1 plus I2 coming from S2 plus 2I cos delta phi, 2 root I1 I2, which is 2I cos delta phi, right? So this gives us cos delta phi equal to half. This gives me cos delta phi equal to half. Yes or no? Right? Now, which means the phase difference must have been like a 2k pi plus pi by 3. Delta phi must have been like a 2k pi plus pi by 3, right? That means delta phi must have been 2k pi plus pi by 3, right? The path difference at P then, must have been the new path difference at P. When the plates were not introduced, the path difference was 0. Now because of the introduction of the plates, the path traveled through the plates is different. Therefore, there is a non-zero path difference at P. That's going to be lambda by 2 pi into 2k pi plus pi by 3. Yes or no? Which is like k lambda plus lambda by 6, k lambda plus lambda by 6 is the path difference. Is it not? But I actually don't know the exact path difference at P because I don't know the value of k that is relevant for P, right? This much that we have arrived at, the path difference at P must be of the form some k lambda plus lambda by 6. I want to figure out the value of k. Now let's look at the additional set of data provided by the problem. Okay, but so far so good, right? Now the problem says that the fifth maximum now shifts below P, whereas the sixth minimum lies above P. Let's use this data to figure out the value of k, right? See, one thing, realize that the entire fringe pattern must have shifted downwards. Say if this is mu1, this is mu2. Do you realize that mu2 is greater than mu1? So we know for sure that the fringe pattern has shifted down. Fringe pattern shifts down by an amount mu2 minus mu1 into t into capital D by small d. That's the amount by which the fringe pattern would shift up. See, this causes it to move up by mu1 minus 1 into t into capital D by small d. This causes it to move down by an amount mu2 minus 1 into t into capital D by small d. So the entire thing now shifts down by this amount. We know that. Where mu2 minus mu1 is 0.3 etc. into t into capital D by small d. That's the amount by which the entire fringe pattern has shifted down. See, when there were no glass plates, Then at P, you saw a central maximum, a zeroth order bright fringe. Then there was n equal to 1, a first order bright fringe, n equal to 2, n equal to 5 was the fifth maximum. This was the fifth maximum, and n equal to 5.5 was the sixth minimum. Do you realize that? Why the sixth minimum? Because see, this is n equal to 0.5 is the first minimum, right? N equal to 1.5 is the second minimum. N equal to 2.5 will be the third minimum. N equal to 4.5 would be the fifth minimum. So n equal to 5.5 would be the sixth minimum. If the order at P was n equal to 5.5, then that would have been the sixth minimum, right? So this then was the fifth maximum, and this was the sixth minimum. Yes or no? What was the separation between the two? Half the fringe width? The vertical separation between the two must be half the fringe width, yes or no? Minimum and nearest maximum would be separated by half the fringe width. So that would have been W by 2, the separation between the two. Right? Where, what is the fringe width? Will the introduction of the plates change the fringe width? No, the fringe width remains same, lambda into capital D by small d. Only the thing that happens is the entire pattern shifts down by the amount that I have mentioned, right? Now, after the glass plates are introduced, the whole thing has shifted down. They say that the fifth maximum now shifts below P, whereas the sixth minimum lies above P. This, after the plates are introduced, this comes here, and n equal to 5.5 comes somewhere here. That's what happens. That's what they say, right? That means now this is the fifth maximum and this is the sixth minimum. This is how it happens after the plates are introduced. That's how the entire pattern has moved down, right? Now using this data, we want to be able to calculate the thickness of the glass plate. First of all, I want to know the value of K. Observe that at P, at this point, what is the path difference? 5 lambda. If the order of the fringe is 5, then the path difference is 5 lambda. If the order of the fringe is 5.5, then the path difference is going to be 5.5 lambda. Path difference by lambda will give me n, right? So P, the path difference at P must be somewhere between 5 lambda and 5.5 lambda. Path difference at P must be greater than 5 lambda and less than 5.5 lambda, right? So the path difference at P, the path difference must be less than 5.5 lambda, must be greater than 5 lambda. Yeah? That means K lambda plus lambda by 6 is the path difference at P. Now, you can find the range of K from here and you can find the range of K from here, but I don't want you to do that. Just observe one very simple thing. If K was 5, this will be greater than 5 lambda, right? But less than 5.5 lambda, isn't it? See, because then this will be 5 plus 1 by 6, which is less than 5.5. So do you see out of inspection alone that K must be 5? So that this becomes greater than 5 lambda, but less than 5.5 lambda for K equal to 5. So can I not conclude that K must be 5? Can I not conclude that K must be 5? Yes or no? Right? So K is 5. right? Therefore, if k is 5, I now know exactly the path difference at P. So put k equal to 5, 31 lambda by 6. Now this will become 31 lambda by 6, the path difference at P. Yes or no? Is that okay? Now, my problem is still not solved. I need to find the value of T, for which the path difference at P becomes 31 lambda by 6, right? Can I just remove this clutter from here? See, if these slits were not there, right, then there would be no path difference. If these two plates were not there, there would be no path difference at P. If only the upper one was there, then the upper path at P would be longer than the lower path by an amount mu1 minus 1 into T. If only the lower was there and the upper was not there, then the lower path would be longer than the upper path by mu2 minus 1 into T. But now that the upper and lower both are there, right, the additional path that this provides on reaching P is mu2 minus 1 into T, whereas this provides an additional path mu1 minus 1 into T. Therefore, the path difference at P would be mu2 minus 1 into T minus mu1 minus 1 into T is the path difference. Yes or no? That's a path difference at P. Do you realize that? That's a path difference at P. Mridul, nahi na? Sure ho? I don't have a problem explaining again. Dekho, kuch nahi hai. See, if I have to write the path difference at P, all right, S2P optical minus S1P optical is the path difference at P, right? S2P optical would be what? S2P geometrical plus the additional path that this provides, S2P optic geometrical plus mu2 minus 1 into T is the optical path for this. In the absence of the slit, it would just have been S2P, but because in absence of the plate, sorry, but when the plate is present, this is the extent to which it gets strengthened, the path gets strengthened by this amount, okay, minus S1P optical. S1P optical is actually S1P geometrical plus the additional path that this provides is mu1 minus 1 into T. So what's the path difference at P? Mu2 minus 1 into T minus mu1 minus 1 into T is the optical path difference at P. Clear? So the path difference at P then is like a mu2 minus mu1 into T is the path difference at P, which is 31 lambda by 6, which is 31 lambda by 6. So this is 0.3T is 31 lambda. Lambda is 5400 into 10 to power minus 10 into 10 to power 6 microns. Isn't it? Multiply by 10 to power minus 10, you will get meters, and then multiply by 10 to power 6, you will get microns. That means if you multiply by 10 to power minus 4, and you get microns. Isn't it? Isn't it? So you can convert this lambda into microns by multiplying 5400 by 10 to power minus 4. Isn't it? And then you can get the thickness in microns. You can get the thickness in microns of the two films that are there. Is that all right or not all right? Right? Let me explain the next problem then. Can I wipe this off? Is this settled? All of you have understood everything that I have said on this? Right? In the next problem, a double slit apparatus is immersed in a liquid of refractive index 1.33. That means now the YDSE setup is not carried out in air. S1, S2, but in a medium of refractive index 1.33. There is a slit separation D equal to 1 mm, and there is capital D, which is 1.33 meters. The slits are illuminated by a parallel beam of lambda in air, lambda naught means lambda in air, of 6,300 angstroms, right? Calculate the fringe width. Now, if it was not in a medium, then the fringe width would have been lambda naught capital D by small d. But what does the medium do? It decreases or scales it down by a factor mu m. So, the fringe width in the medium would be what it was in air divided by mu m, would have been the fringe width. Yes or no? You can calculate this now, whatever this turns out to be. Okay. Now, so this is all right, right? One of the slits is now covered by a thin glass plate of refractive index 1.53. Say the upper one is covered by the upper one of mu equal to 1.53 and of thickness T covers the upper slit, right? Now, what is the objective? We want to find the smallest thickness of the sheet to bring the adjacent minimum on the axis. Now, when this was not there, when this was, what does this do? This would move the entire fringe pattern upwards. So then, you know, in absence of this, this was the central maximum. When this plate was not there, this was the central maximum. And what is it that you're seeking? This, at a distance w by 2, was a minimum. At a distance half the fringe width was a minimum. And you want this to come to this point. You want this to come to this point. See, the entire fringe pattern would move up. So then, this adjacent minimum moves to O. That means we are shifting the fringe pattern by an amount w by 2, wm by 2, wm by 2. Yes, yes, why not? See, what would this do? This is of refractive index higher than the surroundings. So then this will move the fringe pattern upwards. If this was of refractive index smaller than the surroundings, it would have shifted the fringe pattern downwards, right? Now, what we are seeking is, when this plate was not there, this was a central maximum. This was a maximum, right? The nearest minimum below this would be half the fringe width. And you want this nearest minimum to go to O. That means you want the vertical shift of half the fringe width. Half the fringe width is the vertical shift that you are seeking. Yes or no? Right? So the vertical shift sought is half the fringe width. Now, just to recap some things. At O, now when this or at any point P on the screen, distance y, right? Any point P on the screen y, what's the optical part difference? Mu m times S2P minus mu m times S1P plus the additional optical path that this provides is going to be mu minus mu m into T is the additional optical path that this provides, right? For constructive interference, it must be an integral multiple of lambda, right? Now, if you want a central maximum, then n will be 0, right? So for a central maximum, n is 0, n is 0, That means mu m times S2p minus S1p must be mu minus mu m into t. Right? Therefore, S2p minus S1p, which is the part difference, is mu by mu m minus 1 into t. Right? But what is S2p minus S1p? Y into small d by capital D? This is y into small d by capital D. Right? That means now the central maximum is no longer y equal to 0. Central maximum is y equal to mu by mu m minus 1 into t into capital D by small d. Earlier the central maximum was y equal to 0. Now the central maximum is this. Yes or no? Do you all realize this? Whatever I have done here? Right? That means the entire fringe pattern has moved by this amount. Right? With the introduction of the slit, with the introduction of the plate, the entire fringe pattern moves by this amount. Clear? And this amount must be half the fringe width. This amount must be half the fringe width, isn't it? So this Wm by 2 must be mu by mu m minus 1 into t into capital D by small d. Right? Wm by 2, Wm half the fringe width is lambda naught by mu m into capital D by small d. Capital D by small d will conveniently get cancelled. Mu minus mu m into t, and this mu m in the denominator will get cancelled with this mu m in the denominator, and you can solve for t. You can solve for t. The required thickness, that will bring the nearest minimum onto the, yes. Kunta? Sorry, by 2. Yeah, this 2 I missed out. By 2, absolutely. So one thing in a medium of refractive index mu m, introduction of a glass plate, again remember this, in a medium of refractive index mu m, the introduction of a glass plate will shift the fringe pattern up by this amount. Yes or no? This is what would happen. Mu by mu m, this is what? Mu of this with respect to the surroundings. If the surroundings were air, then this would be, mu m would be 1. Then it will be mu minus 1 into t into capital D by small d. The shift upwards. The shift upwards in air would have been mu minus 1 into t into capital D by small d. But in the medium, it's going to be not mu in air, but mu with respect to the medium. That means mu by mu m is what you're going to use. Clear? Sounds all right now? Let's look at the third problem. You must do all the calculations, you know. Make sure you do that, because never get into a habit of being like a teacher who says you do the calculations. A teacher is eligible to do that. He has done the calculations when he appeared for the exams. He doesn't want to do the dirty job anymore. All right, you can spare him from that. But you better do that fast. Very fast, because in an actual exam you can't get lazy. You need the answer, you need one of the options. So until and unless you do it in practice while you are solving problems at home or in the class, you will not do it in the exam. So you must do it in class. I'm leaving it at this point, but you make sure that you take the answer to its natural conclusion. Make sure it matches to the decimal. Clear? So problem 3, which is about white light being used to eliminate the 2 slits in a Young's double slit experiment. the two slits are being illuminated by white light, and the separation between the two slits is B. The separation of the screen as before is capital D, much larger than small b. At a point on the screen directly in front of one of the slits, this is the point P, directly in front of one of the slits. That means the y of this point is b by 2. The y of this point would be b by 2, isn't it? We want to find the missing wavelengths. Now, understand. A wavelength would be missing if it has interfered destructively, because then its color will not be available. It will just give you a dark fringe, right? Then those wavelengths would be missing at that point. At the point P, if you are seeking the missing wavelengths, that means you are seeking wavelengths that have interfered destructively, then they are not prominent anymore. You know what I'm saying? At P, then you are seeking the missing wavelengths. Those would be ones that have interfered destructively at P. Therefore, they will not make their presence felt. Right? So, missing wavelengths are those that have interfered destructively at P. Clear? Right? So, missing wavelengths at P would be the one that has interfered destructively. Those are the ones that have interfered destructively at P. Say, lambda is the missing wavelength at P. See, white light has all wavelengths in it, right? So, amongst them, lambda is the wavelength of the missing wavelength, right? So, then at P, what's the path difference? The path difference at P is y into small d, in this case, B by capital D. That's the path difference. Right? Where y is what? Y is b by 2. Y is b by 2. If you want the lambdas, some lambdas to be missing here, then this must be an odd multiple of lambda by 2. This must be an odd multiple of lambda by 2. Then these lambdas would be missing. Lambdas satisfying this condition would be missing. Yes or no? That means the lambdas that would be missing at P would be lambda equal to b squared by an odd number into d. B squared by an odd number into d. Right? That means b squared by d, b squared by 3d, b squared by 5d, those would be the missing wavelengths. For different odd numbers, you will get various missing wavelengths at P. Clear? Right now? You look at the next one. Problem 4. Again, a YDSE arrangement. Slits S1, S2 separated by a distance 10 mm. And being illuminated by a wavelength which is 6000 angstroms. And there is a perfectly transparent film of thickness T perfectly transparent film of thickness T and of refractive index 1.5 placed in front of S1. We want to find okay, let me do the second part first. There is a point A such that the power at A is a minimum. We want to find the thickness T such that the power at A is a minimum. That means intensity is minimum, right? So now where is that point A? That point A is here with y equal to 0.48 mm. And capital D, as usual, much larger than small d, is given to be 2 meters. Right? Now, what is it that you're wanting? You're wanting a minimum at A, isn't it? A maximum at A. You're wanting a maximum at A. Now, minimum? Oh, minimum at A. Minimum at A. Okay. Let's say when this was not there. Let's say when this was not there, when the plate was not there. Absence of plate. Absence of plate. What was the path difference at P, at A? Path difference at A would have been y into small d, that is 10 divided by 2000. This would have been the path difference at A, y, which is 0.48 mm, to small d, which is 10 mm by 2000 mm, right? So these many mm would have been the path difference at A, right? The order at A would have been this divided by lambda. This divided by lambda would have been the order at A. So the order at A would have been the path difference by A. That means before introduction of the plate, path difference at A divided by the lambda, that is 6000 angstroms, 10 to power minus 10 meters into 10 to power 3, that means 10 to power minus 7 millimeters, right? Can you just tell me what this turns out to be? Is it an integer? How much is it? 4. So the order of interference at A turns out to be 4, say. That means at A there was a case of constructive interference before introduction of the plate, right? Now, this was n equal to 4 before introduction of the plate. Now the nearest minimum to this was n equal to 3.5, which needs to be moved up. N equal to 3.5 needs to be moved up. This was the nearest minimum. That means all that we are seeking is a vertical shift of half the fringe width. This must be instrumental in bringing about a vertical shift of half the fringe width. This is what we want. Such must be the thickness of the glass plate. So that a vertical shift of half the fringe width occurs, right? Half the fringe width means lambda into capital D by small d. That's half the fringe width. And what is it equal to in terms of the thickness of the glass plate? This must be mu minus 1 into T into capital D by small d. This will bring the nearest minimum at A. Right? And of course, once you do that, then T can be easily obtained. Capital D by small d will get cancelled. I mean, don't do all calculations with capital D and by small d, because chances are that they will get cancelled somewhere. So leave them intact, so that you they're not involved anywhere. On many occasions that might happen. Right? Do you all understand this? Now the first part of the problem is find the power at A as a function of t. Now at A, realize that before the plate was introduced, the phase difference was an even multiple of pi. Why? Because it was constructive interference, right? So it was as good as 0. It was as good as 0. In any case, once the plates are introduced, then the phase difference on introduction of the plates will not just be the 2k pi that was originally there, but would also be the phase difference brought about by the plate. What's the phase difference brought about by the plate? The path difference brought about by the plate is mu minus 1 into t is the path difference, into lambda by 2 pi is the phase difference brought about by the plate alone. And 2k pi was already there. Because this, before introduction of the plates, this was constructive interference. So 2k pi was the phase difference already. Isn't it? Now after the plates were introduced, this was an additional phase difference brought about. Part difference was mu minus 1 into t. Additional part difference into lambda by 2 pi. Right? So cos delta phi then must have been cos of mu minus 1 into t into lambda by 2 pi. Now the power at A would be given by the power coming from 1 plus power coming from 2 plus 2 root P1 P2 cos delta phi. Now the only difference here is, see, the power would be given by intensity into area of the slit. See, the length and the width of each slit is known. So the power from the slit would be the intensity in watts per meter squared into meter squared, which is the area of the slits. Right? You know what I'm saying? The power from S1, for example, would be the intensity from S1 into area of the slit S1, which would be length into width. So those you can plug in and obtain power as a function of T by plugging in all of this. In problem 5, we have an arrangement of the following kind. There is a source S illuminating S1 and S2. And this is, say, Y naught equal to 1 mm. And this distance was, say, capital D naught equal to 1 meter. 1 meter. S1, S2 was D given as 10 mm. Right? We are now next talking of a point right in front of S1, which is this point, which has Y equal to 5 mm. আরে দেখিস ভাই ভূত ফুত ঢুকে গেছে মনে হচ্ছে এর মধ্যে তান্ত্রিককে ডাকবি কালকে ভূতটা বার করতে হবে বুঝলি रुद्र हाँ बाबा बाबा तुम तो जाते होगे शमशान में ये सब करने तुम ही पता नहीं भूत घुसाए हो लगता है हमको तो तुम ही बाबा हो यहाँ के तुम ये सब विद्या तो तुम ही को आता है भूत घुसाना भूत निकालना भूत बनाना नहीं नहीं भूत बोल रहा हूं और कुछ नहीं बोल रहा हूं ओके ऑल राइट ऑल राइट ऑल राइट capital D is 2 meters. This is O. We want to find the nature and order of interference at P and at O. At P and at O. So, see, so all that we need to do is path difference divided by lambda will give me the interference. So, at P, the path difference is SS2 plus S2P minus SS1 plus S1P. That's the path difference at P, right? This is like SS2 minus SS1. SS2 minus SS1 will be Y naught into small d by capital D naught, right? SS2 minus SS1 plus S2P minus S1P. I can rewrite this like this, right? Where SS2 minus SS1, SS2 minus SS1 is like a Y naught into small d by capital D naught, right? And S2P minus S1P, S2P minus S1P would be Y into small d by capital D. That's the path difference at P, delta x at P, right? The order of interference at P would be delta x at P divided by the wavelength lambda naught. Have you calculated this? How much? 70? Okay, this turns out to be 70. That means it's a maxima at P. It's a maxima at P, right? The path difference at O, see at O, S1O and S2O are equal paths, right? So the only path difference is SS2 minus SS1 is the path difference at O, because S1O and S2O are equal. So the path difference at O, the path difference at O is simply going to be SS2 minus SS1, right? And which is like Y naught into small d by capital D. Have you, right? And by D naught. So the order of interference at O is going to be delta x naught by lambda naught. Have you done this calculation? 20. Okay, so this turns out to be 20. That means again, this is n equal to 20, this is n equal to 70. Both are bright fringes, of different orders, right? Now, where should a film of refractive index mu equal to 1.5 be placed, and what should its thickness be, so that a maxima of 0 order is produced at O? Hey, realize that before I introduce the slits, the plate, S2 is stronger compared to S1 because, you know, it has an additional path already before it started, SS2 minus SS1. So, on reaching O, we never got a central bright fringe. The central bright fringe must have been below O, isn't it? In this arrangement, the central bright fringe must have been below O. This must have been n equal to 0 must have been somewhere here before I did anything in this arrangement, right? Now what is it that I'm wanting to do? I'm wanting to shift this to O. That means I want to move the entire fringe pattern upwards. By what amount? Between n equal to 0 to n equal to 20, the vertical difference is 20 times the fringe width. 20 times the fringe width, yes or no? So this is like 20 times W is the vertical shift that I'm trying to produce. 20 times the fringe width is what I'm trying to move it up by, right? That means I must place it right in front of S1. There are two ways we can do it. I'll just tell you this and then another one. I must place the plate in front of S1. Now this would move it up by what amount? The plate will move it up by an amount, mu minus 1 into t into capital D by small d, and this must be 20 times the fringe width. That means this must be 20 times lambda into capital D by small d. Capital D by small d gets cancelled, and you'll be able to calculate t. Yes or no? That's one way to do it. Do you all understand this? Right now? The other thing, see, if you want a 0th order fringe here, then you just place, see, the additional path that this one has is annulled by the additional path that this will have. That means the additional path mu minus 1 into t must be equal to ss2 minus ss1. So that the net path on reaching O will be the same for both the waves. Yes or no? That means you could have simply said mu minus 1 into t takes care of this difference ss2 minus ss1, so that on reaching O, they would have traveled equal amounts of optical paths, right? But ss2 minus ss1 is simply y0 into small d by capital D. Clear? Make sense now? In fact, we know that if it's a 0th order, if it's a 20th order fringe here, then this should have been 20 times lambda. And ss2 minus ss1 must have been 20 times lambda. So see, 20 times lambda, mu minus 1 into t is 20 times lambda. Either way, it all matches, right? Clear now? Shall we proceed? So far so good, right? Two parallel beams this is one incident normally on a prism. If intensity of the upper beam is 4i and the intensity of the lower beam is I, and their incident, let's say, so these, they are referred to as P and Q, or what we could do is, might as well use this to label these points P and Q. This one goes undeviated because it's incident normally. This one goes undeviated because it's incident normally. And now they get refracted and then are brought to focus. At some point. If the intensity of the upper beam is 4i, the intensity of the lower beam is I, then we want to find the resultant intensity at the focus F. See, say this distance is small d, and mu is the refractive index of the material of the prism, right? These are points R and S. Okay. say this angle is some theta, theta. That means this is the normal at the point of incidence R. This is say 90 minus theta, and it emerges at an angle alpha, say. Right? Now, before emerging, they have a path difference. What is the path difference? This is the path difference. Before, see, this one emerges from R, this one emerges from S. This mu into this length will be the path difference. This is the optical difference. This is the geometrical difference. Mu into this length will be the optical difference, right? So, this length, as you can see, is d cot theta, isn't it? D cot theta is this length, right? So, just before emerging, from R and S respectively, the optical path difference, OPD is optical path difference between the two waves, is what? Mu times d cot theta. D cot theta is the geometrical difference, mu times d cot theta is the optical path difference. Now, so this one, let me call this 1, 2. D has an additional optical path travelled before it emerges. How much more? Mu d cot theta is the additional optical path that 2 has over 1 before it emerges, right? Now, on emerging, let's say till this point T. After this point, they would have travelled equal amount of optical path. But till this point, 1 would have an additional optical path, this length. 1 would have an additional optical path, which would be this length. Now, what would this length be? Realize that if this is d, this is d by sine theta. This length is d by sine theta is this length, isn't it? This length is d by sine theta, right? And this length is 90 minus alpha, right? So now what is RT? RT would be RS cos 90 minus alpha. RS cos 90 minus alpha, right? Isn't it? That means RS sin alpha, RS sin alpha, right? Yes or no? Where what is RS? RS is d by sine theta. Sin alpha, right? So now, after this, there is no further path difference. So the entire path difference would have been RT minus mu d cot theta. RT minus mu d cot theta would be the path difference when they interfere at F. On interfering at F, the optical path difference would have been RT minus mu d cot theta. Is that settled? Right? Now, realize that when I apply Snell's law at this point, right, then I have mu times sine 90 minus theta is 1 into sine alpha, right? Applying Snell's law at this point, mu into sine of the angle of incidence is 1 into sine alpha, right? So that gives me sine alpha equal to mu cos theta, right? So if I plug in sine alpha equal to mu cos theta here, then I get mu d cot theta. When I get mu d cot theta, that means till this point mu d cot theta minus mu d cot theta, path difference would have been 0 from this point onwards. Therefore, they would travel in phase. Therefore, phase difference at f is going to be 0. Yes or no? Or equivalently 0. Right? So then at f, we could look upon delta phi as 0, and the intensity at f is going to be 4i plus I plus 2 root 4i squared cos delta phi, which is 1, 9i. Therefore 9i would be the intensity at